Welcome, data architects and engineers. Today, we are diving into a transformative feature currently in public preview, Snowflake Semantic Views. Let's explore how to define your business logic directly within the database. Let's start with a foundational definition. What exactly is a semantic view? In short, it is a native, schema-level object stored directly inside your Snowflake database. Think of it as a universal translator. Traditionally, databases are built for storage efficiency, resulting in cryptic column names like AMTTTL pre-DSC. However, your business users speak in terms of gross revenue. Semantic views bridge this massive gap. They act as a business-friendly abstraction layer, defining what the data actually means in real-world terms. By creating these views either through standard SQL DDL commands or Snowsight's AI-assisted wizard, you embed business logic right next to your data, ensuring a single source of truth across all your analytical applications. Looking at this flowchart, you can see the strategic position of the semantic view. On the left, your business users and AI applications ask questions using standard business terminology. Instead of hitting the physical tables directly, their requests are intercepted by the semantic view. This view acts as the brain, translating a concept like gross revenue down into the complex physical reality of AMTTTL pre-DSC stored in your tables on the right. This decouples your business logic from your underlying storage architecture. Why should you adopt semantic views over traditional reporting tables or external BI semantic layers? The value proposition targets three distinct groups. First, for AI applications like Cortex Analyst, semantic views are the secret weapon. They provide the LLM with strict, rule-based definitions, ensuring your AI generates accurate, hallucination-free SQL. Second, for business intelligence, it guarantees consistency. Whether a user is in Tableau, Power BI, or an internal app, net profit is calculated the exact same way. Third, for you, the technical analyst, it drastically simplifies your life. You define complex joins and formulas once in a centralized location, rather than duplicating code across hundreds of disparate queries. Furthermore, because these are native Snowflake objects, they perfectly inherit your existing role-based access control and data sharing policies. This architectural graph demonstrates the hub and spoke benefit of semantic views. Notice how the semantic view layer sits at the center of your data ecosystem. It absorbs your centralized metrics, join logic, and native RBAC security policies from the bottom. Then, it serves as the single source of truth radiating outward to all your consumption endpoints, Cortex AI apps, enterprise BI tools, and data science notebooks. Update a metric definition once in the center, and it instantly propagates across your entire enterprise. To build a semantic view, you must understand its 5 core anatomical components. First, we define logical tables. These represent your core business entities, abstracting away the messy physical tables into clean concepts like customers or orders. Inside these logical tables, we define dimensions, which are the categorical attributes you use to slice your data, like region. Next are facts, representing raw, unaggregated numerical data, such as a single sale amount. We then build metrics on top of those facts. Metrics are your aggregated KPIs. For instance, total revenue might be defined as the sum of the sale amount fact. Finally, and critically, we define relationships. These are predefined join paths that tell the database exactly how to connect the customers table to the orders table, ensuring downstream tools never make a bad join. Let's map out these concepts using a class diagram. The overarching object is the semantic view, which contains the critical relationship definitions. This view is composed of one or more logical tables, representing your business entities. Zooming into a logical table, you can see it encapsulates dimensions for context, facts for raw numbers, and metrics for aggregated KPIs. By structuring your metadata this way, you are teaching the database and any AI querying it the exact anatomy and vocabulary of your unique business model. Implementing semantic views is highly flexible, offering paths for both coders and business analysts. The most robust method is using native SQL DDL. You execute a create or replace semantic view statement, explicitly declaring your tables, facts, dimensions, and metrics within the query. If you prefer a visual approach, Snowsight offers an incredible AI-assisted generator. You feed it your most important historical SQL queries, and the AI automatically reverse engineers the relationships, tables, and column descriptions for you. For organizations migrating from older architectures, you can use the system$create semantic view from YAML stored procedure to instantly convert legacy YAML files into these new native objects. An insider tip, Always provide representative, non-sensitive sample values in your view definitions. This gives Cortex AI a massive accuracy boost when interpreting ambiguous user questions. This flowchart highlights the three primary creation pathways converging into a single result. Whether your data engineering team writes raw SQL DDL commands, your analysts use the Snowflake AI wizard to parse history, or you programmatically convert legacy definitions via the YAML stored procedure, they all result in a native semantic view object. Once created, the vital final step is injecting sample values, enriching the metadata so that downstream large language models have flawless context for natural language generation. Security is paramount, and this is where native semantic views vastly outperform external semantic layers. Semantic views operate using owner's rights. This is a massive security benefit. It means your end users or your AI agents do not need any direct privileges on the underlying, highly sensitive physical base tables. You simply grant them the select privilege on the semantic view itself. The view acts as a secure, governed gateway. Furthermore, you have granular control using access modifiers. You might have a complex discount rate fact that is required to calculate net revenue, but you don't want users querying discount rate directly. You can explicitly mark that fact as private access, hiding it from public visibility while keeping the net revenue metric public. And natively, any row access policies on your base tables flow right through the view. Examine the security flow. The end user or AI agent on the left is heavily restricted. They only need, and only receive, select access to the semantic view itself. They are completely blocked from the protected base tables. The semantic view, executing with elevated owner's rights, reaches down to pull the necessary data securely. It then filters the exposure. Public metrics are made visible to the user, while private facts, used only for internal math, remain strictly hidden. It is a perfect zero-trust boundary. The most exciting application of semantic views is their integration with Snowflake Cortex Analyst. Cortex Analyst is a sophisticated, fully managed agentic AI that allows business users to type questions in plain English and receive instant, accurate data. But an LLM cannot guess your business logic. The semantic view serves as the literal brain for Cortex Analyst. By feeding the LLM your exact metrics, synonyms, and join relationships, you eliminate AI hallucinations. The integration is so deep that it supports stateful, multi-turn conversations. If a user asks for 2023 revenue and then simply follows up with "What about Asia?", Cortex Analyst uses the semantic view to instantly resolve the context and generate the new SQL. You can even embed custom instructions directly into the semantic view definition, such as telling the AI to always round currency metrics to 2 decimals, enforcing enterprise formatting standards at the AI level. This sequence diagram illustrates the life cycle of a text-to-SQL query using Cortex Analyst. The user asks a natural language question. Cortex Analyst doesn't just guess, it immediately queries the semantic view to fetch the exact mathematical definition of net profit and the required table join paths. Armed with this absolute truth, Cortex Analyst generates flawless SQL and executes it against the Snowflake compute engine. The final, perfectly accurate results are then returned to the user in seconds. The semantic view guarantees the AI gets the math right every single time. Let's crystallize this with a real-world use case. Imagine a VP of global sales who wants to literally chat with her data to uncover insights. She types, "Show me total revenue by region for 2023. The problem, your physical database is highly normalized. Answering that requires joining the orders, customers, and regions tables and applying a complex formula for applied discounts. A generic AI would fail miserably. The solution is for the data engineering team to deploy a semantic view named Global Sales Analysis. Inside this view, they explicitly define the total revenue metric as price minus discount, and they map the exact many-to-one joins connecting the tables. Now, when the VP asks her question via a Streamlit interface, Cortex Analyst reads the semantic view and instantly generates a perfect 4-way SQL join, delivering accurate executive insights without a single BI ticket being filed. Let's trace the VP's experience through this workflow. Her raw text query enters the Cortex Analyst engine. The engine references our Global Sales Semantic View. It extracts 2 critical pieces of information, the mathematical metric for revenue and the exact join paths across the 3 normalized tables. Combining the user's intent with the view's strict logic, it generates and executes the SQL in the background. The VP's dashboard updates instantly with the correct numbers. We've turned a complex engineering task into a self-serve conversation. As we conclude our training, let's cover enterprise deployment best practices. First, treat your semantic views as production code. Store your DDL or YAML definitions in a Git repository and deploy them automatically via CI/CD pipelines. If you use dbt, you can seamlessly integrate this using the dbt semantic view package provided by Snowflake Labs, allowing you to materialize these views right alongside your standard transformations. When designing your models, use an iterative approach. Start small with a clean star schema for one specific department, like marketing, prove the value, and then expand. Finally, always include verified queries in your definitions. These are gold standard questions and their matching SQL that act as training wheels, ensuring Cortex Analyst achieves near 100% accuracy on your most critical KPIs. Thank you for joining this deep dive. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Our final diagram shows the gold standard deployment architecture. It begins on the left with your code safely in a Git repository. Your CI/CD pipeline triggers a dbt transformation run. Thanks to the dbt semantic view package, Snowflake executes both tasks simultaneously. It updates your physical tables with the latest data, and it deploys the updated semantic views to match. The end state on the right is a fully synchronized environment where your governed AI analytics are perfectly aligned with your physical data layer.